today's lesson, we continue on the topic why L'Hopital rules fails. Usually it is because of the condition when you use L'Hopital rules. Most people don't realize that. They just use L'Hopital rule whenever they want. So there are two conditions of using L'Hopital rule. Most people are aware of the first condition, that is, it must be of the form 0 over 0 or infinity over infinity. That is the first condition. The second condition is actually the method of getting the limit. That is, we differentiate both numerator and denominator separately with the condition, and that is important, that if this itself exists or it is equal to either positive infinity or negative infinity, then we can use the L'Hopital rule. So the main question right now is, the L'Hopital rule fails. It is because it does not satisfy the second condition. That is, the limit of the right hand side does not exist and not equal to either positive or negative infinity. The condition is very important, otherwise you will have a lot of problem. Let's say, for example, we always use the condition of square root a b equals square root of a square root of b. Now there's a condition for this algebraic manipulation. That is, a and b must be greater than or equal to 0. But most people don't really care about that, and they might have a big problem. And a classical example would be square root of 1. That is, we know that it will take a non-negative value, and we say that 1 equals to negative 1 times negative 1, and in this case a equals to negative 1 and b equals to negative 1. If we apply whatever we have in the equation above, then we will have square root of negative 1 times square root of negative 1. And as you know, this will equal to I, and this is I squared, and that is equal to negative 1. With this, we just prove that 1 equals to negative 1. Then there is something wrong. Now, there's another misunderstanding. Since the condition say that a and b must be greater than or equal to 0, then this is true. Without the condition, it may still true, but it's just that we are unable to prove that. That's why we are not included in the condition. It is always happen when we deal with linear algebra for first year course in university. And the condition always say that the square matrix must be invertible, because the proof of showing not invertible usually is a lot harder. So bear in mind with the condition, and it's only safe to use it within the condition. Without the condition, you may still get the correct answer, but using wrong reason. So I'm now going to give you one example to illustrate the idea when the right hand side does not exist. So for this example, it fulfills the first condition, because when x go to infinity, the numerator go to infinity and the denominator go to infinity. Now, if you are going to use L'Hopital rule, we have to differentiate the numerator, which I have 1 plus cosine x. And for denominator, we will have 1. Now we have a problem now, because when x go to infinity, the value of cosine x is always bound in between negative 1 and 1. And it does not have a fixed value. So the limit of cosine x when x go to infinity does not exist. We say that in this case, the limit of 1 plus cosine x does not exist. So when this limit does not exist, it means that the original limit does not exist. The L'Hopital rule doesn't say anything about that. The L'Hopital rule only say that after you differentiate separately and the limit exists, then the original limit exists and will equal to whatever you have there. But it doesn't say what happens when this limit does not exist. In short, the original limit may or may not exist, but we can't use L'Hopital rule at all. So how to deal with this question? This question is not that difficult. We just need to separate it, and we have 1 plus sine x over x. limit of 1 when x go to infinity still the same, equals to 1. And limit of sine x over x will be equal to 0. We can show it using squeeze theorem. Note that sine x is in between -1 and 1. And for positive x, we can divide everything by x, and it doesn't affect inequality signs because of the limit of -1 over x when x go to infinity and the limit of 1 over x when x go to infinity, both of them the same and equals to 0. By squeeze theorem, the limit of sine x over x must exist, and it has nowhere to go. It must be equal to the same limit, right? So the limit of sine x over x when x go to infinity is equal to 0. So in this case, we can separate them, and the answer is equals to 1. Using this example, we know that not all the question in limit of the form 0 over 0 or infinity over infinity that can be done using L'Hopital rule. That's all for today's lesson. I'll see you again. Bye-bye.